All right, welcome Alan, Trevor, and Sean. I'm so glad to have you with me.
Thank you.
Nice to be here.
Great to be here.
We're gonna dive right into our first question. Tell us how you or your company, if you're able to do so, or you see the industry using edge computing and then cloud computing. Sort of like how are they blending the two? So Alan, why don't we start with you?
Yeah, sure. As a manufacturing company, we have lots of different applications, but from my background in terms of advanced analytics, which I can speak from pretty heavily, we're mostly in the edge realm at the moment. Primarily, a lot of what we're doing is focusing on piloting, and for sure, edge is easier for us in a pilot mode. But we have come across applications where we need the power of an offsite database. And so for at least one of our machine learning applications, we're using the cloud. But for sure, in terms of edge, in terms of getting information from sensors quickly, that's where we're focusing on premises computing power.
All right. And Sean, how about you from a manufacturer's perspective? It's always nice to hear what you all see out in the marketplace, since you see so many different manufacturing companies and how they work and their processes.
Yeah, so we're seeing a lot of manufacturers focusing on both condition and prediction-based quality management to be deployed out on the edge and cloud, or a hybrid version, if you will, as well as looking at end-of-line test time reduction. And the reason for those particular use cases is typically we see the predictive models that are being executed being built in a centrally managed cloud, deployed to the edge, and then the analytics that are leveraging data from IoT-enabled sensors are deployed and executing those actions on the edge.
All right, great. And Trevor.
Yeah, so for Toyota, we've got our IoT program in full swing, and we are deploying right now at the edge and centrally, as mentioned, in a hybrid type environment, but mainly on the edge. You know, our plants are very large. Our WAN links are smaller and less reliable in some of the remote locations that we have from a manufacturing perspective. So we've got use cases where we're pushing that model to the edge and doing some predictive maintenance models at the edge today, and as we grow and expand, we're expecting that to be even more in the future. We do have a couple of use cases that we're doing centrally, and we've had some issues with WAN latency, so that's definitely a concern that we're addressing through the edge compute.
All right, so there, I have heard about latency problems with the cloud, also cost. Is that a consideration as you weigh which option to use, or is it mostly for speed and and the data that you can get from it?
Yes. Yeah, so for us, just back to that example, it's the big thing is the latency that we're seeing, right? And if you're relying on that processing to happen in the cloud and being sent back, it can cause latency issues, and that's our biggest concern. So there was one use case for modeling that we're doing in a centralized cloud environment, and we ran into some issues. So we're pushing that to the edge now as a result of that. So that latency is the biggest concern.
Anybody else have anything to add on the latency versus cost issue?
I can say from our perspective, in terms of the long-term, investment strategy, the cost is something that we do weigh in terms of cloud versus on-premises or edge. And so that does come up, but when we're in piloting, I would say it's really a non-issue. It just becomes which is the most efficient way to handle it. And at the moment, we're not trying to do anything that's sub-second processing from the cloud at all. So we're not there yet in our industry, probably, in utilizing cloud for anything where latency would be an issue, at least not yet.
Right. So I'm going to start with you, Sean, on this next question. What are the best use cases for quote unquote near edge versus far edge processing?
Yeah, so as Alan brought up before, looking at latency, if you are going to be measuring response time in milliseconds, then clearly getting to the near edge is as large of a requirement as possible. Simply because if you have a slow round trip time from your device through your network to your analytics and then to action or back to the device again, typically the further you move that away, the longer latency it is, as opposed to having a near edge deployment. The issue though with near edge in terms of having the ideal mix on the factory floor is that the near edge typically has a smaller amount of processing power, which can limit the amount of data that you're plugging through your algorithms on a per second basis, which means you might need more near edge devices as opposed to fewer far edge devices. So it's really a support versus time trade-off that you're making when deploying on the near edge or the far edge.
Okay. Trevor, anything to add to that?
Yeah, for us, we're looking at both, right? Near edge for us would be kind of our computer rooms in the manufacturing facilities within North America operations, and then our true edge would be, running on, small form factor PCs at the process, right? And right now, our use cases that we're deploying, for example, are video processing, where we're looking at evaluating, did a team member perform a process correctly? Using those cameras and that higher speed data that you need it's really conducive to the edge, but we are looking at the near edge as well in that computer room as a viable option as we start to expand the number of video devices on the floor. And then we're also doing some weld inspection, for example, where we're checking inspection process. Of course, that needs to run so quickly at the microsecond. It has to be at the edge almost for that use case. But we're, evaluating that near edge as well.
Excellent. Alan?
Yeah, from our perspective, most of the data we're dealing with is time-based, time series data. And a lot of vendors are promoting, at least from a cost perspective, wireless technology for sensors. And the advertisement sheet would say this has a lot of computing power. It can do all of the waveform translations right there in the device itself. But there's a tremendous trade-off that we're finding pretty quickly between having that computing process power at the sensor with battery life. And so far, there's a trade-off there. So that's it's a delicate balance of where you do that processing power. I think it's probably in the middle. It's not necessarily in the cloud, but having it at the sensor level, at least with battery technology, is probably a difficult pill to swallow for us right now. And the cost of wired sensors is a lot more than wireless. So there's just a cost trade-off for us.
Got it. So that brings up sort of the next question about what other technologies and connectivity are needed to properly support edge on factory floors. And who wants to start with that? Sean, how about you?
Yeah, so the first is, I'll say centralized monitoring. And that's really centralized monitoring of sensor performance as well as device and equipment performance. And then, of course, being able to integrate the back end of that data and turn that into actions, whether it is simply directing data to an HMI so that a worker can reflect and understand what's going on, or whether it's something a little bit more complex where you are scheduling a task inside of a CMMS automatically, or ordering spare parts or consumables based off of condition monitoring of that piece of equipment. Or lastly, sending instructions back to the piece of equipment to change its behavior. All of that requires additional information that really can't be stored at the edge and has to be accessed fairly quickly and robustly.
Great, thank you. And Trevor?
Yeah, so today we have mostly wired and wireless technologies, Wi-Fi specifically, but of course we run into constant issues with Wi-Fi connectivity in our plants with all of the competing steel and you know, moving devices. So Wi-Fi has been a big challenge. You know, we're going to do some pilot of some newer technologies this year that go beyond that, to see if there's some opportunity. Of course, you know, cost is a big thing, right? When you run wired connections down to these edge sensors, it's very expensive, and also really negates the benefit that you get from having the sensor initially. So I think it's a big concern. 5G, you know, is around the corner. I know we're doing some potential pilots with that, and if we can make that work, I think really the plants will explode with sensors if we can make that work, to be frank. But predictive maintenance sensors, we've got around 9,000 out in our factories across North America. All of those are using either proprietary 900 megahertz frequencies or our Wi-Fi, you know, 2.4 or 5 gigahertz frequencies that we have today.
Great. Well, we'll migrate then to 5G, because obviously connectivity and speed are important here. So Alan, do you want to tell us what role you see 5G playing in this endeavor?
I think at least for our company, it might be a bit too soon to tell. I can tell you that for a legacy industry like pulp and paper, many of our mills are not in locations with great connectivity. So you may go to some of our mill sites that barely have a cell signal, and much less in, say, the basement of one of our paper machines. And so that's a real challenge for us to push the limit with cutting edge technologies, maybe even technologies in the past 5 years, not so cutting edge without that connectivity. So we're, I guess, patiently and optimistically in a wait and see as to what exactly 5G will be. My fear is we might need to be looking ahead of what's next, and just making sure whatever we apply is capable of going upward in mobility.
Mm-hmm.
But for sure, if we can go wireless, that's the way we'd like to go, because you know, as Trevor said, the cost of running wires and there's a safety issue with that working in an operating plant is just sometimes we don't have a choice, but we'd like to be wireless in the future. That would be the goal.
All right.
And Maureen, just to clarify, on our plants are in the middle of nowhere in many cases as well. So what we end up with this pilot we're doing is we're having to work with the carriers like the AT&Ts of the world to do kind of in-plant private, you know, 5G type of environments as well. So and you know, whether that's going to be cost conducive and, you know, in the future with these big facilities, that's yet to be determined. So we may be in the same position that Alan is as well.
Yeah. Sean, how about your perspectives on 5G and what's coming, and is it going to be all the great things they say it is?
I think it's going to be, and I have to agree with Trevor in terms of it appears as though if once 5G gets worked out and deployed correctly, there's going to be an explosion of sensors inside of plants, because not only are they cheaper to procure when they're wireless, but the cost of maintaining them is less, as well as deployment. If you're just attaching a sensor, connecting it to the network, and having it start streaming data wirelessly, it's a lot easier than having to run physical cable to that particular sensor or device. It also can be much easier to troubleshoot based upon network suitability and robustness, which you're able to analyze quickly as well, because it's a large, robust network. So really, I have to absolutely agree with Trevor and his observation of the plant is just going to light up with sensors.
And when do we have any sense of when that will be, when the 5G will be at the point where you will be able to see that kind of exponential growth? Anybody?
Yeah, I think it'll occur after you have the first several large plant lighthouses, pardon the expression, fall off the cliff. But once there are specific proof points of the value that's delivered and how that value was delivered, you'll quickly see fast followers lining up to follow those initial lighthouses and obtain those benefits as well.
Yeah, that makes
I
sense.
think for us, it's going to come with somewhat of a curve because I think that there has to be some testing and making sure that they're going to perform. The sensors are going to be able to stay connected and perform at the same level as the current wired connections do. So I see it growing exponentially, but I think it's going to be a little later, maybe for manufacturing than other industries, just because of that reliability factor and the availability of interfaces from the machine makers as well.
Yeah, I mean, somewhat related to this, and I'd be curious to hear what Sean and Trevor have to say, but one of the challenges I can foresee, especially when we get into more and more wireless sensors, and they're not going to be all one manufacturer, they're going to be many different manufacturers, is getting all of this wireless data back into our data archive. And so this is great. Lots of vendors like to sell sensors and they want to send their data to the cloud and do their manipulation and sell you a service. But our goal in life is to keep that data on premise, just as if it was wired. And that's going to be, I think, some kind of protocol challenge to get that kind of consistency for all the 5G sensors that might be developed.
Alan, are you guys forking the data from these from the vendor solutions into your own data lake, or are you keeping it in with the vendor environment?
So I guess you could say we're not playing so nice because here from Atlanta, I'm International Paper. We're doing the remote monitoring like you were talking about, Sean. So we want the data, and we may not know exactly what we want to do with it, but we know that we want it and we want to combine it with non-traditional sources. So it's something that we came across as a necessary evil, is to stipulate that those vendors would need to comply with some type of way of communicating the data back to our historian. And we're using the OSI soft historian, which is pretty normal archive, but those vendors, whoever they might be, speaking to all of our facilities, would need to comply and get that data back to the Pi system in a robust manner. And that's been a little bit of a challenge so far.
Yeah, for us too, Alan. I'd definitely be interested to hearing talking a little bit more with you about that and understand how you're overcoming that, because we run that challenge as well with egress fees back into our data lakes if you don't fork that data from the edge or from the source. So
right.
Sean, did you have anything to add to that conversation?
No, it's a good point they bring up, and it also brings up a large discussion on IoT architecture, which is, do you leverage a vendor that has a point solution that's pre-built, that's absolutely focused on the specific initial use case you have in mind, but then of course you're kind of limited in flexibility, or do you look at vendors that facilitate more platform flexibility, but don't necessarily have the 100% out of the box use case one ready to go, and you're trading off initial speed for complete long-term flexibility, as well as I'll call it inherent vendor knowledge that they've also put in and built in their platform, and said this is the way this thing's going to work for this point solution, as opposed to that long-term flexibility of, you own the data, where do you want the data, do you need it to go to a shared cloud, do you want it to go on your cloud, do you want it to go to your historian before it hits the cloud, or do you want it to go through the edge analytics, then to a historian, and then out to a cloud that could be, and I'll use cloud synonymously, from a in-plant data center to a regional data center to a private cloud to a shared public cloud.
Yeah, I see
it
it as
could.
a new evolution, really, right? So everybody's used to wired sensors. They have the data, it's on the premise, and it gets to the historian. You want to add a sensor, you wire it up, it's in your historian. But now it is so much cost effective, so much more cost effective to buy that wireless, and you don't even think about it until you get the data and you realize, well, it's going off site with a cell tower. Now we got to get it back in, and it sounds like an easy process, but sometimes it's not all that easy to get it back, to get the data back with the right timestamp, for example.
Right.
So
Yes, and that's the trick, is when does the timestamp occur? It should be occurring as the data is leaving the sensor,
that's
but
right.
is it occurring when the data is leaving the
Or
cloud?
conditioned. That's right.
Yeah.
Interesting. Wow. Okay.
Devil's in the details.
Yeah,
Mhm.
for sure. So importantly, what other technologies are best supported and enabled by the edge and or the cloud, and such as IoT, AR, VR, artificial intelligence? I mean, what other things is it foundationally supporting? Alan, you want to start us off there?
I can say we're not too far with the augmented reality type spaces yet, but certainly that will be there. In terms of the near term future, I think the cloud is a tremendous source for just taking photographic comparisons of samples. I've seen lots of cases for that, coming with off spec just from a camera shot, set off site to the cloud. It's the computer determines what he's seeing, and it comes back. To me, that's just tremendously powerful. Even from a safety standpoint, it can detect when things are not safe or someone's not performing safe work. But in terms of the most of our analytics, it's still done, in our servers, not necessarily at the far edge, but it's still within our realm of control. A lot of, I guess there's power in having time lag data in a manufacturing plant that's could be days from when the feedstock comes in to the product goes out. Having a database that's time lagged, that's tremendous power in using a cloud for that. But to be honest, we're just testing the waters with the power of the cloud, and trying to figure out exactly what value we can pull out of the massive amount of data that we've had for decades. And it's really a fun time to be in the industry for that. We're not so far ahead as other industries, but we're starting to see that light of what we can glean from looking at data we didn't even know existed. So
Uh-huh.
Yeah, similar
Or how about
situation.
you?
It's a similar situation for us, Alan. We've kind of created two different paths within our data and our manufacturing environment. We've got the traditional path, and then we've got the new IoT platform with machine learning and advanced analytics. The traditional path, we've got tons of data. Data from traditional systems. We've got your traditional data collection systems where you've got data in tons of SQL servers at the plants, and one of our activities this year is to take that data and start to migrate it towards the our data lake environment, whether it be local on-prem data lakes or in the cloud data lakes, and start to contextualize that data so that you can start to do something with it in a longer term trending and analytics perspective. So as we start to see that those data sources from the new IoT machine learning environment and our traditional data environment start to come together, we see that happening in that lake environment. So building that out is a high priority, and focusing first on that data that's going to provide the greatest benefit from the business side of things is what we're focused on right now.
John, anything to add to that in terms of what other technologies edge can support versus the cloud?
Yeah, I mean, we cover them, and what Trevor and Alan were talking about is something that we see from a manufacturing perspective is really, again, the aggregation of that data, but the aggregation that we see is a little bit differently, meaning we're enhancing existing production equipment with IoT-enabled sensors, and we want to pull data either from the existing PLCs or from an OPC UA server and run it through streaming analytics or a complex event processor or a predictive model in real time. And the sensor data is vastly more valuable when you're able to have the controller data alongside of it and mixing it. So that's how we're seeing a lot of manufacturers really approach the subject, is looking at it the opposite way. And then of course it all goes into that back end big data lake so that you can perform the historical analytics to examine trends, as well as to allow for machine learning tools to create or refine predictive models, again, to be used against that data as it's streaming.
Right, right.
Yeah, I always say we're in the midst of setting our data free.
Yeah.
You
It's
know,
been trapped.
it's
been
been in
locked up.
it's been in silos.
Silos, yeah.
And now we're trying to break that loose, which it sounds a lot easier than it is.
That's right. Yep. That's same here too.
So what are the cybersecurity concerns around edge versus the cloud, and any pushback from your IT departments on your movement into more edge computing at your factory floors? Trevor, do you want to start?
Yeah, be happy to. Yeah, well, I'm in IT, so the pushback would come from my group. Yeah, we actually, part of the agile team that we've set up includes a dedicated member of our cybersecurity team, and they're engaged in every conversation that we have, and it's definitely something that we've been focused on, especially in light of all the different ransomware activity that's out there in manufacturing right now, and we've really kind of buckled down a bit on our security measures on the plant floor ever since WannaCry. So it's definitely been a focus. We, with our IoT solution, we're using a mechanism to have some embedded security end to end that allows us to push down our models in a very secure environment, and so that's been a big focus. And of course, traditionally, we've amped up our security with additional tools just in the last couple of years that allow us to do active 24/7 monitoring of all of our manufacturing environment. So very important activity.
Yeah, outstanding. Alan?
Yeah, I'm definitely not in IT, but I have definitely worked with them. Our group, who knew we would be as integrated with IT as we really are, which I think really truly is the future of the two groups working together. But in terms of security, for us, it's a lot easier to do things on the edge. There's not as much red tape to cut through. But over the past couple of years, we've deployed to the cloud and hasn't really been an issue. So it just takes longer. So I think I led off the discussion saying, in terms of piloting, we recommend doing it on the edge because we know that environment. Let's do it there. But I think we have the flexibility in many cases. As Sean was saying, it's a hybrid approach. For most cases, we're using both to accomplish the same within the same project. We're using both edge and cloud capabilities.
Right. And Sean, what do you see out there with all the manufacturers that you work with? Concerns about cybersecurity with the edge, or how are they approaching it?
No, I'm for the manufacturers I'm working out, they really aren't concerned with security at all. No, I'm just kidding. It's a bad joke there. But yeah, in all seriousness, there's always a huge concern with any type of operational data when it leaves the plant, simply because it's very, very sensitive data. However, what's interesting, at least from the wonderful year of 2020 that was, and hopefully isn't repeated anytime in the future, the intrusions that occurred across multiple different manufacturers mostly stemmed from someone opening an email that they shouldn't, which is unleashing some sort of a malware attack then internally, instead of I'll call forced intrusion through an operational site. Is that because the operational network security is that robust that hackers won't even try to get in? Possibly. Is it because that the weakest link to security is actually a person instead of a firewall or anything like that. That to me, that seems more like the better answer.
Yeah.
So when you're evaluating, do I keep this on premise? Do I look at the cloud in terms of sending data out? I think that the real question has to be what's the most likely way that an intrusion is going to happen, and it depends on how confident you are in your people and reacting and understanding what's a great way to mitigate risks as opposed to trusting a vendor or trusting a private cloud network, anything along those lines.
Gotcha. All right. So when it comes to ROI, a recent Gartner report recommends, quote, focusing investment on new edge applications that deliver ROI in under 2 years to counter the risk of edge immaturity and support all edge deployments with system management, monitoring, and security tools. Do you agree or disagree? And if so, just explain one way or the other. Alan, you want to start?
I mean, I would say in terms of piloting, that would be great. That type of ROI would get us off square one with those type of projects. And so I don't have too much experience to answer directly to the question other than that would be easier for us to implement at the edge from our experience, and having that type of ROI would certainly keep things moving. So I would agree from my perspective.
John?
So I agree with Gartner's statement, but not because of their focus on the immaturity rationale. So I disagree with their rationale at the back end. When you look at edge deployment, an edge is just a server in effect. And the size of that server can be as small as a Raspberry Pi, or it can be as large as a gateway. But typically servers are fairly mature. Alongside of that, you have network connectivity, whether it's MT-Connect, MQTT from a protocol perspective for IoT, or whether you're using a wired or wireless connection. It's still fairly mature. And then when you come to the analytics, whether it's streaming, complex event processing, or predictive analytics, those three technologies are very mature. Where I think Gartner is coming from is they're looking at companies that are trying to create new forms of analytics to drop specifically on the edge because they previously built real-time analytics that just they don't scale well. They don't scale up, they don't scale down, and so they're looking at a shoehorn type of approach, which means it's test it, see what works, and keeps going on. If you're able to look at more mature analytics that scale up to all of them, i.e., it's the same form of analytics I'm using on the edge as opposed to the data center, as opposed to the cloud, then you're able to deploy successfully and easily. But what I do agree absolutely with Gartner on is the ROI maturity. I have a saying which is rules before tools, which is what is my problem, what's my payback going to be, and then we'll figure out what's needed to resolve that particular issue.
Got it. Good one. Trevor, anything to add to those thoughts on the Gartner?
You're take off mute. Sorry, my dogs
No
are barking in the background, so I wanted to mute that out. Yeah, I agree with Sean completely. On the key for us would be this: the speed will be completely dependent on the ROI or the business case. Right now, we've got a backlog of opportunities. We'll call them opportunities, use cases, if you will. And really the speed that we go will really depend on the benefit that we can generate from the use cases and working with the different business groups in the factory floor. So some use cases recently that we've done have allowed us to go very fast because they have big return on investment. In the cases of energy and quality, and now we're starting to see more use cases around productivity, which is a little harder to justify. So things are starting to slow down, if you will. So I think it really depends on what kind of business value you can get from the use cases in terms of will really drive how fast we adopt.
Outstanding. Well, that wraps up all of my questions, but are there any last pearls of wisdom, something I didn't ask you that maybe you would like to impart to the audience that we didn't get to? Or Alan, anything from you?
No, I think, we covered, from my perspective, we're doing both. We're open to both. Whereas, 5-10 years ago, we would not have been. So this is a much better when you can open your eyes to all the realms, and including the hybrid approach. That's good. And it's just going to come down to, if we're piloting, probably we'll move to the edge. If we're not, it'll come down to a financial decision and whether or not we really need the speed of processing. If we can handle latency, then we would consider it based on the cost aspect.
Right. Sean, anything from you? Any final words?
Yeah, whenever you're evaluating whether you want to use edge devices or centralized servers or private clouds or public clouds, when you're looking at the plant, the other issue that always seems to be just kind of skipped over is short and long-term support. I mean, even if it's a Raspberry Pi, you're going to have to support that device, both from an application standpoint and from a physical standpoint. And usually from a physical standpoint, it's not going to be the plant electrician that's going to be in there working on that. So when you're making that evaluation criteria, you should also be cognizant of who's going to be here to resolve any issues in the short and long term, and what impact is that going to have on my current and future staffing needs.
Great. Thank you for that. Trevor, how about for you?
Yeah, no, I agree with what Alan and Sean just said, especially around the support coming from the IT point of view. Make sure that you've got a good support mechanism in place when you're making evaluating the decision for that. And I would say the other one, based on our experiences, is look at performance and performance at scale. Right, as you start to scale up. As we talked about, some of this may balloon here very soon. So really look at the scalability of when you start to look at the edge versus the near edge versus the cloud. So I would say that's a big factor to consider as well.
Awesome. Well, I thank you very much, gentlemen. This is an outstanding conversation, and I'm sure you've opened up the eyes and the ears of everybody listening. So thank you so much for your time.
Yeah,
You're
my
welcome.
pleasure. Glad to be
Enjoyed
here.
it.
Thanks for having me.